Hi guys, and welcome to lesson 1 on zero and negative exponents. So what are exponents and why do we use them? An exponent is a shortcut for writing repeated multiplication expressions. In this exponent that I have here, I have parentheses negative 15 raised to the third power. So another vocabulary term that we use for exponents is power. And essentially, we have two parts of our power. We have a base, which in this example is negative 15, and we have an exponent. And that exponent is going to basically tell us how many times we're going to use the base as a factor, how many times we are going to multiply that factor, which here is negative 15. As you can see in this example, in its expanded form, I have negative 15 times negative 15 times negative 15. That's 3 times. Okay, let's dive into some vocabulary here. I have a table, and in my table, I have 3 powers. And we're going to go ahead and we're going to identify the base and the exponent in that power. In my first example, I have negative 4 raised to the second power. So my base is negative 4, and notice how I have parentheses, and my exponent is 2. So when I evaluate that power, I'm essentially doing negative 4 times negative 4, 2 times, and that's going to give me positive 16. Okay, let's see what happens when we have a power that's raised to the 0 power. My base here is 2, and my exponent is 0. When this happens, you are always going to get 1, and this is due to the 0 exponent rule, which states that any value raised to the 0 power is going to give you 1. This applies for all values of a except for 0. So we're going to take a look at these 2 examples that I have here. In the first example, I have 987 raised to the 0 power. And in the second example, I have x raised to the 0 power. Notice how in one example, I have a number as a base. I have 987. And in the second example, I have a variable. But they're both going to give me 1. And this is due to the 0 exponent rule. For all values, it could be a number, it could be a variable, as long as it's not 0, if that base is raised to the 0 power, is going to be 1. All right, so we saw what happens when our exponent is 0. Let's take a look at what happens when our exponent is negative, which I know can sometimes be a little scary. So in this example, the last example in my table, I have 2 raised to the negative 2 power. My base is 2 and my exponent is negative 2. Now, when we have a negative exponent, we are going to get a fraction. Guys, here I have 1 over 2 to the second power. And that's because the negative exponent rule states that any value raised to a negative exponent is essentially going to give you the reciprocal of that base, but now you have a positive exponent. Okay, so what does reciprocal mean? A reciprocal is when you are flipping a fraction. So if you take a look at this example right here, I have 4 over 3. If I find the reciprocal of that fraction, I'm essentially flipping it, which means that the original numerator is now the denominator. So let's take a look at our first example here. I have 7 raised to the negative 5th power. I can represent this same value as a fraction. All I did, guys, is I put a 1 under my base. I have 7 raised to the negative 5th power, and I put a 1 under it. That doesn't change the value of that number, okay? I'm showing you guys this because I'm going to show you that I'm going to flip it. I'm going to get the reciprocal. So right now, I have 1 as my denominator, right? When I flip it, it's going to be my numerator. Notice how now my 5 is a positive exponent. In the negative exponent rule, you're taking the reciprocal of your original problem of your base, right? Of your power. And then instead of having a negative exponent in your denominator, you're going to have that same exponent is going to be positive. Okay, so let's take a look at the second example. I have parentheses, negative 9, close parentheses, raised to the negative 3rd power. I'm going to represent this value as a fraction. All I did is I put 1 under my entire power, under my entire base there. I have a 1 as my denominator. When I flip it, I'm finding the reciprocal. I'm flipping it, guys. This is my final answer. I have 1 as my numerator now, and in my denominator, I still have negative 9 as my base, but my exponent is now positive. Okay? All right, so let's go ahead. Let's do a couple more examples. And the biggest takeaway from today's lesson is we have our zero exponent rule, which states that any value raised to the zero power is going to give you 1. So if you look at example 1, I have 99 raised to the zero power. That's going to give me 1. What do you guys think about the next problem? Now you try it. 7 raised to the zero power. You can pause the video if you like. Okay, awesome. I hope you guys saw that it's going to give you 1. Okay, any value that's not 0 raised to the 0 power is going to give you 1. All right, so now we're going to do examples 2 and 3. And I know that we're combining both of our rules, but we're going to take it step by step. Okay, the first thing that I see in an example 2 is I have x raised to the 0 power. I know for sure that's going to give me 1. But now I have y raised to the negative third power. I'm going to apply my negative exponent rule, which states that I'm going to take the reciprocal of my base, and now my exponent is going to be positive. So I'm going to represent that part of y to the negative third power as a fraction. See how I put a 1 under it? Now that I can clearly see the fraction, I can flip it. I can find the reciprocal, which is 1 over y to the third power. And now the third power is positive, guys. And my final answer is just going to be 1 over y to the third because I'm multiplying it by 1. All right, now I want you guys to really try. Pause the video, look at your problem. You have 87, and then you have x to the 0 power. Okay? All right, I hope you guys saw that x to the 0 power is going to give you that 1. And because it's right next to the 87, that represents multiplication. 1 times 87, it just gives me 87. All right, last example here, example 3. I have 7 raised to the negative fifth power. I want to go ahead and I want to show you guys this same value, the same term as a fraction. Notice how I put a 1 under it. Okay, I can clearly see where the 1 is. And now I'm going to find the reciprocal because the negative exponent rule states that if you're raising a term to the negative power, you are going to find the reciprocal of that same base, and your exponent is going to be positive now. So I flipped it. I have 1 over 7 to the fifth power. Now you guys can pause the video and try it yourselves. I know that you guys got this. Let me go ahead and show you guys the same problem as a fraction. Notice where the 1 is, and now think about how you can flip it. Think about what your reciprocal is going to be. Awesome, guys. You have 1 over 3 to the second power. Thank you so much for watching this video, and goodbye.